The core concept is recognition. An equation is quadratic in some function, f of x, if it follows this structure: a times the function squared plus b times the function plus a constant c equals 0. To solve this, we use a technique called substitution. We let a new variable, u, represent the entire function f of x. This transforms the complicated expression into a standard quadratic equation in terms of u. We then solve for u using factoring or the quadratic formula. The most important step is back substitution. Once you have the values for u, you must set f of x equal to those values and solve for the original variable x. This is where most marks are earned in your exam. Let's apply this to a polynomial of a higher degree. At first glance, this is a quartic equation, but notice the relationship between the powers. Since x to the power of 4 is simply x squared, we can see it fits our quadratic pattern. We let u equal x squared. Substituting this into our equation gives us a standard quadratic. We can factorize this easily, which gives us two possible values for u. Now, we must back substitute to find x. If e equals 4, then x squared equals 4, so x equals plus or minus 2. If u equals 1, then x squared equals 1, so x equals plus or minus 1. In the exam, always check if you have found all possible real values for x. Graphically, we can see the curve crosses the x-axis at these 4 distinct points. Let's look at the concept behind visualizing these equations. Visualizing these equations helps us understand why we get multiple solutions. Look at the graph of the equation we just solved. Notice how the curve crosses the x-axis at 4 distinct points: -2, -1, +1, and +2. The graph is symmetric about the y-axis because the powers of x are even. When we solve the quadratic in u, we are essentially finding the horizontal levels that produce these intersections. The valleys of the graph reach down to -2.25. Because our original equation set the function equal to 0, we found all 4 roots where the graph hits the x-axis. If the constant term in our equation was different, we might have only 2 roots, or even none at all, depending on whether the horizontal line y equals 0 intersects the curve. Always keep this geometric perspective in mind. Next, let's look at equations involving square roots. This is a common exam trick. Notice that x is the square of the square root of x. This allows us to treat the square root as our base function. Let u equal the square root of x, where u is greater than or equal to 0. Crucially, when we define u as a principal square root, u must be non-negative. This restriction is vital for later. By substituting, we get a quadratic. We can factorize this as 6u squared plus u minus 1 equals 0. Factorizing gives 3u minus 1 multiplied by 2u plus 1 equals 0. This gives us two possibilities: u equals 1/3 or u equals -1/2. Now we apply our reasoning. Since u represents a square root, it cannot be negative. We reject the solution u equals -1/2. Finally, we back substitute. Square root of x equals 1/3. Squaring both sides gives us our final answer. X equals 1/9. In Cambridge exams, failing to reject the invalid root will often cost you an accuracy mark. Another common appearance of hidden quadratics is in trigonometry. If you see a squared trigonometric term and a linear one, rearrange it to equal 0. By subtracting 1 and tangent of x from both sides, we create the quadratic form. Here, our function f of x is tangent of x. Let u equal tangent of x. This gives us the standard quadratic u squared minus u minus 1 equals 0. This particular quadratic doesn't factorize nicely with integers, so we must use the quadratic formula. Substituting back for tangent of x, we have two separate equations to solve. To find the final values for x, you would take the inverse tangent of both values and find all angles within the range specified in the exam question. Always ensure your calculator is in the correct mode, degrees or radians, as required by the paper. The discriminant is your most powerful tool for predicting the number of solutions without solving the entire equation. For our substituted quadratic in U, the discriminant determines its nature. If the discriminant is greater than 0, there are two distinct real values for U. If it equals 0, we have one repeated real value. And if it is less than 0, there are no real values for U. However, here is a critical Cambridge-level observation. Real values for U do not guarantee real values for X. Even if U has real solutions, X might not exist. For example, if you are using the substitution U equals X squared, and your calculation gives you U equals -4, then X squared equals -4, which has no real solutions. In this scenario, the quadratic in U has a real solution, but the original equation in X does not. Always consider the range of your substitution function, such as X squared or the square root of X, when interpreting your results. Let's look at an exam-style question. Solve the equation. X minus 5 times the square root of X plus 6 equals 0. Let's solve this Cambridge-style problem step by step. It involves a fractional power, as the square root of X can be written as X to the power of 1/2. Step 1 is to identify the substitution. Notice that X is the square of the square root of X. So, we let U equal X to the power of 1/2. Then, U squared equals X. Step 2, substitute and solve the quadratic. Replacing X and the square root of X in our original equation gives U squared minus 5U plus 6 equals 0. This is a standard quadratic that factorizes easily into U minus 2 times U minus 3 equals 0. This gives us two possible values for U. U equals 2 or U equals 3. Step 3, back substitute to find X. Now we return to our original variable, X. Since U equals X to the power of 1/2, if U is 2, then X is 2 squared, which is 4. Similarly, if U is 3, then X to the power of 1/2 equals 3, which means X equals 3 squared, or 9. Our final solutions are X equals 4 and X equals 9. Both values of U were positive, so both lead to valid real solutions for X. In a 9709 paper, this would typically be worth 3 or 4 marks. Always show the substitution clearly to secure the method marks. Let's look at where students often lose marks in the 9709 examinations. First, forgetting to back substitute. The most frequent error is solving for U and stopping there. Remember, the question asks for X. If you leave your answer as U equals 2 or U equals 3, you will lose the final accuracy marks. Second, failing to reject invalid roots. As we saw earlier, if your substitution involves a function with a restricted range, such as a square root or an even power, you must check if your U values are valid. If you state that X equals 4 when the square root of X was -2, you have made a conceptual error. Third, incorrect squaring of terms. When identifying your substitution, be very careful with your algebra. Expanding brackets or identifying that X to the power of 1/2 squared is X must be done precisely. Finally, calculator mode errors. In trigonometric versions of these questions, ensure you are working in the correct units. If the range is given in radians, your final answers for X must be in radians. To maximize your marks in the Pure Mathematics 1 paper, keep these examiner insights in mind. First, always explicitly state your substitution. Examiners award a method mark for clearly identifying that the equation is quadratic in form. Even if you make a calculation error later, this statement secures your first mark. Second, always check the validity of your final answers by substituting them back into the original equation. This is especially important for equations with square roots or fractional powers, where fake solutions can often appear during the squaring process. Third, look to factorize before jumping to the quadratic formula. In Cambridge papers, hidden quadratics are often designed to factorize nicely with integers. If you find yourself dealing with very complex decimals, pause and check if you have identified the substitution correctly. Finally, unless otherwise stated, give non-exact numerical answers correct to 3 significant figures and angles in degrees to 1 decimal place. Leaving him answer as a surd, like square root of 2, is usually safer unless the question specifies a decimal format. It is time to test your understanding. Please pause the video and attempt these 3 questions before we go through the solutions. Easy. Solve x to the power of 4 minus 13x squared plus 36 equals 0. Medium. Solve x minus 7 times the square root of x plus 10 equals 0. Hard. Solve 4 times x to the power of negative 2 minus 5 times x to the power of negative 1 plus 1 equals 0. Take your time with the substitution and be careful with the negative powers in the hard question. Pause the video now. First, the easy question. We have x to the power of 4 minus 13x squared plus 36 equals 0. Let u equal x squared. This gives us the quadratic equation. U squared minus 13u plus 30 to 6 equals 0. Factorizing, we get u minus 9 times u minus 4 equals 0. So, u equals 9 or u equals 4. Back substituting, x squared equals 9 leads to x equals plus or minus 3, and x squared equals 4 leads to x equals plus or minus 2. The final solutions are x equals 3, negative 3, 2, and negative 2. Now for the medium question. X minus 7 times the square root of x plus 10 equals 0. Let u equal the square root of x. Then, our equation becomes u squared minus 7u plus 10 equals 0. Factorizing gives u minus 5 times u minus 2 equals 0. So, u equals 5 or u equals 2. Since both values are positive, we can back substitute. The square root of x equals 5 leads to x equals 25, and the square root of x equals 2 leads to x equals 4. Finally, the hard question. 4x to the power of negative 2 minus 5x to the power of negative 1 plus 1 equals 0. Here, we let u equal x to the power of negative 1, which is 1 over x. The equation transforms into 4u squared minus 5u plus 1 equals 0. Factorizing this expression, we get 4u minus 1 times u minus 1 equals 0. This means u equals 1 over 4, or u equals 1. Back substituting for x, 1 over x equals 1 over 4 leads to x equals 4, and 1 over x equals 1 leads to x equals 1. To summarize the essential points from today's lesson, first, always look for the pattern where one exponent is exactly double the other, such as x to the power of 4 and x squared, or x and the square root of x. Second, clearly define your substitution. Letting u equal the inner function transforms a daunting equation into a standard quadratic that you can solve with confidence. Third, do not stop once you have found the values for u. The examiner is looking for the values of x. Always return to your original variable to secure full marks. Finally, be mathematically rigorous. If u equals a square root or an even power, reject any negative values of u before you calculate x. And as a final check, verify your answers. This simple step can save you from losing avoidable marks in your Pure Mathematics 1 exam.